Hi guys, last time I filmed a video about how to test a transformer with an oscilloscope, and some of my friends are asking for the Spanish version of it, and also I think we can improve that kind of video with the English version too, so let's record it. When I have a transformer, most of the time I have a transformer with some writings on it. I have the identification, which one is the primary, which one is the secondary. And most of the time they are in English, sometimes they are in Chinese, and that's hard to get. Worst scenario, sometimes I don't have any label and I need to figure it out which one is the primary, which one is the secondary, and it becomes worse if I have more than one output in the same transformer. Most of the time in a step-down transformer, the primary is the winding with the higher resistance, and the secondary has very low resistance, almost like a kind of short circuit. So set up your digital multimeter in ohms. We have the primary with 2 wires or even 3 wires. Those 3 wires could be 2 are the main line, 120 to 140. Other could be a center tap when we have transformers for 2 120s, or even it could be a line for a fuse. Primary windings, they're most of the time in the order of hundreds of ohms. Sometimes we have the output in the secondary with 2 wires. Sometimes we have 3 wires because we have a center tap, and many times we can get more than one winding for the output. Different kind of voltage. For this case it's very easy because my center tap is black and the other 2 wires are blue. It's a very low resistance, and this multimeter has high resistance on the cables, on the test leads. But I'm expecting something alike from the center tap to the other wire in the winding. This kind of test is just to find out which one is the primary and which one is the secondary line. This is not the official test to make a measurement in a transformer. This is other kind of test. Using other transformer, I can make an induction to my transformer under test and to find out if it is working fine or if there is a short circuit on it. What I have to do is just to get close and to go away, and I will see a changing in the output voltage. Let's start with the primary because it will generate more voltage. The digital multimeter must go to AC. The output voltage will increase as I get closer to the other transformer. My transformer is 240 to 24 volts, so I could expect a voltage reduction on ratio of 10 to 1. it will always be a little bit more because transformers, they have very low efficiency. They will lose 15 to 20% in heat, vibration, and the field. So in this case, that's the little difference I see here without any load. But the ratio is okay. I set the function generator in 50 Hz, 10 volts. This kind of test could be done with our main line. I never use the main line. The reason, many years ago, I got a Tektronix test probe from my oscilloscope damaged. When I disassembled the probe, I found out it's like a kind of resistor inside and it was black. Why? Because sometimes we use the test leads or the oscilloscope to connect to the main lines. The oscilloscope, if we are doing it right, nothing will happen to it. But we start burning and cooking, sorry by the word, but it's the best way to describe it. Cooking the test leads, the main resistors, capacitors, and everything that in our oscilloscope helps to keep the calibration. That's the reason you always will see me try to keep my equipment in the best condition I can and to avoid any high voltage. Now in the oscilloscope we can see the signal from the function generator. When I place my alligator to any one of these leads, I will make a ground between this point and whichever I choose. Why? Because the equipment is grounded. Because I have a center tap transformer, I must choose the black lead. Now, let's make a connection with this lead and let's see what happened in the oscilloscope. They are in the same phase shift. Let's see what happened with the other lead. They are in different phase shift. My goal for today was to find out the right phase shift in the output. That means the transformer's polarization. Is it the same phase shift? Right? Okay. Now, let's do it like this. This is the negative. This is the negative. This is the positive. And this is the positive with the same phase shift. Now, with the magic tool, we will make a dot. Again, with the magic tool, other dot. This was the homework for today, and I could identify the same polarization output in my transformer. Thanks guys by watching the video. See you next time.